Okay, so this is the road is uniform, non-uniform.
Non-uniform.
So suppose our road is this. You know how a road looks like, yeah? What are they saying? It is AB. Read the question.
Of mass 30 kilograms. And
Yes.
length 40 meters.
Length is 40 meters.
Yeah, length 40 meters and mass 3 kilograms. Versus horizontal in equilibrium.
Yes, horizontal. That's why I made it horizontal.
Supported by two strings. Two strings attached at the ends A and B of the rope. And then the strings make angles 45 degrees and 60 degrees with the horizontal.
Yes.
Find the tension in the string of each of the strings and position of the center of gravity.
Okay. So there is a string here attached here. Yes, at A, ego. And there is another string attached at
So
B.
that's a ladder or hinge body?
It's a hinge body. Like, now this is a rod, not even hinge. To hinge is basically to do this, to support at something. But now this is a rod, you are supporting it from end to end.
Okay.
You understand? But then it's being supported by strings that make an angle 40 degrees and 60 degrees. Yes? Now, our center of gravity, the entire weight, yes, will be at this point. At the point when the strings meet, and then we make an angle of 90. That is where our center of gravity is going to be. Then the weight of the rod is 3 kilograms. Therefore, the force due to gravity will be 3G, the gravitational force. Echo? Should we go on? Now, me and you should agree that since this is 90 and this is 60, then this must be, for it to be 180, this must be 30. There you go. Was it 45 or 40?
45.
45, So this is 40, 45. For this to be 90, this must be 45, and this also must be 40, 45. Do you believe in that? Now, me and you should agree that vertically opposite angles are equal in magnitude. Therefore, this angle here should be equivalent to the whole of this tower. Therefore, this is 75 degrees. Maybe we can call this, of course, in a string there must be tension. This can be tension 1, and this can be tension what? Tension 2. Are we understand? Me and you should again agree that this angle, yes, is equal to this angle. Yes? And what is it? Because angles in a circle should be 360. Now this is 75, this is 75, this is 150. What remains? 210. 210 by 2, 105. So this is 105 degrees, and this is 105 degrees. Make it work. Are we together? By the way, why am I struggling? They are asking for the tension in the strings, and they want to use the Lami's theorem. You get me? I want to use the Lami's theorem. Now, as per the Lami's theorem, I can see here, yes, I want to move from this point, yes, at the intersection of the strings. I can see here, I have 3G. Then, this tension, of course, T1, when I extrapolate this, it continues, yes? So T1, this is T, T1. So what angle is this? You can see it's 105 plus 30. So can I say it is 135? Yes? And then this, yes? This and this T2. Now here we have T what? T2. This angle is 45 plus 105. Are we together, younger? 45 plus 105. That gets us 150 degrees. Then, of course, what we had up, the angle between the tensions was 75 degrees. Should you add them up and they don't total up to 360, then you are wrong. You add and see. So this is,
Yeah, it's 360.
this is an extract of the forces. You told me you are very smart when it comes to Lami's theorem. So this is T1, the force, over the sine of the angle at the base, sine 150. This is equal to T2 over sine 135. This is basically 3G, yes, over sine 175. Sine 75, yes, sorry. Now, I'm going to cross multiply and do mathematics. I can say T1 over sine 150 is equal to 3G is 29.2. What is 3G? It must be 0.4. Wow, I'm still good to go. So I'm going to cross multiply this 3G sine 150 over sine 75. What is the answer? Punch the whole thing in the calculator.
Okay.
29.4 sine 150 over sine 75.
The whole answer is 15.21.
Is 15?
And 615.
Is 15.2186
2186
newtons. Then, by the same reasoning, T2 over sine 135 is also 3G over sine 75, yes? So T2 is basically 3G. You also put it on the calculator, sine 135 over sine 75. So T2 is going to be T2 basically 29.4 times sine 135 over sine 75.
The answer is
21.5223. Of course, newtons. Yours is running up to 4 decimal places. Then, what the other question wanted us to find the position for the center of what? Of gravity. The position for the center of gravity. You know, take moments. Now, suppose we say AB is 40 meters. So the distance from here up to here is basically 40 what? 40 meters. There you go. Then if that is 40 meters, I wanted to take moments. From this point, yes? Now, a moment of the force is defined as the product of force and its perpendicular distance. Yes? If I call this distance maybe A up to the center of gravity, if I call it X. Yes? I'm going to take moments at a point A. If you know how to take moments, you are good to go. A moment of the force is the product of force and its perpendicular distance from the line of what? Of action. We remember very well that the sum of the clockwise moments is equal to the sum of the anti-clockwise moments for any particular body to be in equilibrium. Now, of course, since this one is lying horizontal with these strings supporting it, then this guy is in equilibrium. And if it is in equilibrium, then the sum of the clockwise moments is equal to the sum of the anti-clockwise moments. Me and you should agree that this force is at 90. And therefore we should first bring this T2 at 90. Because if I'm taking moments at point A, this T1 becomes 0. Because it's there. So the perpendicular distance with which T1 has to move from where it is to A, it is 0. Therefore, T1 times 0 remains what? 0. So when I'm going to take moments at point B, I also take moments at point A. Then we shall see. So I'm not taking moments at point A. This one will move this way, and when I bring this to stand here, it also moves that way.
Taking them at point A.
At point A.
Okay.
Yes? So at point A, this one is clockwise. Yes? And this guy will be anti-clockwise. Just that. Just that. The direction matters a lot. This will move this direction. Therefore, anti-clockwise. It is moving in opposition to the movement of the clock. And then this is moving in a direction in agreement with the movement of the what? Of the clock. That's why we call this clockwise and this anti-clockwise. Therefore, I will have 3g times x. Because I've said let this be distance x.
Okay.
Then this is going to be T1 sine 60 degrees. That is the force. A moment of the force, yes, is defined as the force times the perpendicular distance. So I want to first make this distance perpendicular to this force. That's why I have made this force to first be upright, such that it is perpendicular. It's at angles of 90. How have I done it? I have resolved. Oh yes, it is T2, not T1. Yes? So it becomes T2 sine 60. Now it is perpendicular to this distance. So I simply multiply it by our distance, 40 meters. It was 40 meters. Yes? The rest is algebra. We have T2, don't we?
You say G3 times X.
I said
That the absorbing forces are there.
yes.
Now I'm trying to analyze our thing.
3g times x
is equal to that times that.
times this.
Okay.
I am bringing all of them at point A. I bring this to point A. I bring this to point A. I'm basically
You
taking
also say
moments.
it's equal to A because
Yes.
it's in equilibrium.
And when it is in equilibrium, sum of the clockwise must be equal to sum of the anti-clockwise.
Oh.
Are we together?
Okay.
Now, what is important is you understanding that the force must be perpendicular to the distance. Then you just multiply. You get me? Now, can we get x? X is T2. T2 was what? Was 21.522 calculators. Sine 60 times 40 all over 3g. All over 3g. 3g is 29.4. What do we get?
You get 25.35
Yes. 0.35 meters.
No, the 35898.
89, so we can say 3590. Yes?
Yeah.
Yeah. Right in front of these places, you are safer. Yes?
Mm-hmm.
Then, can I now take moments at point B? So if I take moments at point B, of course now T2 will be nullified. Because when T2 stands, the perpendicular distance with which T2 will have to move from point B to point B is 0. And the moment of the force is the product of force and the perpendicular distance. So now, since distance is 0, when we get the force, we multiply by the distance which is 0, we shall get 0. Therefore, this T2, bringing it to point B, will give us no moment. Understood? That's why we also nullify this at this point. So it means we shall have this moving now in the anti-clockwise sense. Then when this shall have this be upright be at 90 degrees to the rod, then this will be clockwise. You get me? So I'm going to say that we shall have 3G. Maybe I can call this distance y. 3G times y, yes, is going to be T1 sine 45, right? Then times now, the distance has to move from here to here, which is of course 40, right? Then my y will be T1, which T1 is 15.2186. Sine 45 is 2/2, then times 40 times 40 over 3G, which is 29.4. So y is going to be now y will be 13.
I guess the answer almost is
13.7 something. 14 will be 14. Yes.
not bad. 14.6411.
Oh, well, not. 14.6411, of course, meters. Now, the conclusion matters. You see here, we are getting different answers. But why? Therefore, the center of gravity is at a distance 25.3490 from A, or at a distance 14.6411 meters from B.
That's what I want to say the answer.
Yeah. Of course, now we are looking for the position of the center of what? Of gravity. You see where I am. I can be maybe 10 meters from the bicycle. Yes? Or 2 meters from the gate. Where is a teacher standing? The teacher is 2 kilometers from the chapel. Or the teacher is 1 meter from the dining hall. I'm near the dining hall, but far away from. We are looking for the position of the center of what? Gravity. So it can be anywhere. What is important is get this plus this, you get 40. Of course, that's why when I gave you the answer. I was simply getting this, I got 40 minus this. Hey, I just did, of course, manipulate this. This is very hard. No. I simply got 40 minus this. Because I knew it is just the other way around. Yeah.
You'll be having answers being in the paper.